Okay, so in this class we will discuss these questions 47, 8 and 6. Okay, the first question 47 on your tuition note. This question is saying like this, just draw along with me, we'll pick up as we do. There is a bucket filled with water. Let us imagine here. So here there is a coin placed in the bottom of the tank. Let us say this is your coin, the real coin here. Okay, and here the water is filled almost to the brim but not full. This is the water. Water we know is the first medium here. First medium. Okay, and then that means the light rays passing first from water into the air. Okay, above the water is, we know, air, and air is the second medium. Right, second medium. And we also know that air is the rarer medium compared to water, which is the denser medium. Okay, now let us say a light ray passed from this coin, from a point on this coin, like this. Okay, from a point on this coin. And then this is the incident ray. Then here where it strikes the interface between air and water is the normal drawn, which is 90 degrees. So because it's passing from denser to rarer, you know the light ray will refract and go away from the normal. That's the rule we learned in our previous class, that when the light ray enters from a denser to a rarer medium, the refracted ray bend away from the normal. So let us say another ray come past here from the same point, another ray come up here, incident ray, and then this also here is the normal, means the 90 degree line, imaginary, at the point of incidence. This ray will also bend away from this normal and come out into air like this. So these are the two refracted rays that come from the denser medium water into the rarer medium air. So because these two rays have bent away from normal, they themselves are going away from each other. So we have to produce them backwards for them to meet, right? So as you produce them backward in the same straight line, they will meet. So where they meet here, exactly meet here, this is the point where the image of this point will be formed. See, this point image will be formed here. So like that, all the points on this coin will refract away from normal and form their corresponding point image in this area. So the image of the coin will be this one. So this is the image of the coin. This is the real coin. So if this is our eye, let us say this is your eye, and now you try to pick up the coin, then you would be seeing this image and not the real coin. So you try to go and pick up the coin, you'll go in this area and you're not able to pick up at one go because your image of the coin is raised up. So that's why you are missing the coin. So the question has been explained to you. Try to pick a coin placed in a bucket filled with water in one go with your eye to one side of the water, like this, on one side of the water. You are not able to do so. Means you are not able to pick up. Why? Because the image is raised. The image of the real coin is raised and you will be trying to pick the image rather than the real coin. This is because the refracted rays are bending away from the normal and causing the image of the coin to be raised. So we will write the answer. You've understood, so you can just follow and write the answer with me. We'll give this diagram and then here you can write here the figure is that of coin immersed in water. Immersed means inside, immersed in water in a bucket. Okay, so the answer for this one will be incident rays, that one. Write along with me, incident rays coming from a point coming from a point on the coin, as you can see in the figure, refract away from the normal Why? Because as they enter from the denser medium, which is water, into the rarer medium, which in this case is your air above the water, right? As shown in the figure. As shown in the figure. As a result, on producing because it's bending away from the normal as you produce the reflected rays, on producing the reflected rays backwards, the point image is formed. This point image here is formed. The point image is formed, which is raised, above the real coin. It's above the real coin, the image. Thus, the same phenomenon takes place for all the points on the coin. The same phenomenon takes place for all the points on the coin. Takes place for all the points on the coin, okay? Because of this, the coin appears, thus the image of the coin appears. Thus, the image of the coin appear raised, okay? Appear raised. So, therefore, you would be trying to pick the raised image of the coin. Okay, so because of this reason, you can just write the answer. So we are not able to pick the coin. Okay, we are not able to pick the coin at. Okay, you are not able to pick the coin at one go, because we will be first trying to pick the image, as we can see only the image, and we are not able to pick, and after 4 or 5 attempts only we are going to be able to pick up, right? So that is your answer. Okay, question 47. Now let us go to 48. Okay. Okay, 48 here. This question number 48 is actually activity 10.8. Okay, on the textbook it will appear as activity 10.8 textbook on page 181. Let us write the question first. It says, place a large shallow ball. Place a rather large shallow Shallow is the opposite of deep, so the bowl should not be so deep, means water level should not be so deep. On a table, okay, on a table, and put a coin in it, and put a coin in it. Full stop. Move away slowly from the ball. Move away slowly from this ball, okay, from the ball, the container, that means ball. Stop. Slowly you move away and stop. When the coin just disappears, from your sight, so you cannot see anymore from your sight. Okay, then what is the question saying? Continuing. Now ask a friend. After that, ask a friend to pour water gently into the bowl, gently, because so what, without disturbing the coin. So the friend that you ask should pour slowly so that the original position of the coin is not disturbed. You see that the coin is now visible. When your friend do that, you see that the coin is now visible to your eye. Question is saying, why are you able to see now when the water is poured? That means it is something like this. This is the container, let us say, water, and then the coin is there. You can see it. You move away in such a way that this part blocks your view. You cannot see the coin anymore. Just like that. Then your friend slowly pour water, and when the water is filled to some level, you are able to see the coin that you were not able to see just a moment ago. Now, why are you able to see when the water is poured? That's what the question is asking. So let us see here. You can take the diagram, draw a ball, shallow. Shallow means not deep. So this is the ball. Okay, so I think you need some space down. So let's just take some space here. So here, this is the ball which is shallow, let us say. Now the coin is put here. This is the coin, let us say. Then you are here. Your eye is in such a position here, your eye. Where, wait, let's just explain it and then we can do later on. Now, so you move away your eye to this place where you cannot see the coin anymore. Then your friend pour the water, maybe to some level. He pours it up to your water. So this is the water poured. We know this is the ear above water. So now, why, when the water is poured, you are able to see the coin? The reason is because of this. Let us take a point image on the coin. It come here, and it will bend away from the normal. You know, the refracted ray. Let us say another ray come from the same point. Two rays are coming, incident ray. This also will bend away from the normal, like this. So these two refracted rays, they will meet only when you produce them backwards. So we do that, produce backward. Then they meet here. As you can see, they meet here. So this is the point here. So this here refract away from the normal and produce backward. The point image of this point is formed there. So the image of the coin will be formed here because all the points on this coin will go through the same process and form point images. Point images. So this is the image of the coin. Now the image of the coin is raised, right, above the, it is above the This is the one. So the coin is going to be looking like this above. So this is the image of the coin. So your eye was here initially. Let us say we draw it a little bit more. You were here, this part of your eye couldn't see. Here your eye was there. Because of this part of the container, okay, because of this part of the container, you were not able to see. Right, so because of this part of the container, this portion blocking your view, you couldn't see this coin. But because water is poured, the image is raised. Therefore, you are able to see the image, even though you cannot see the real coin. So that is the reason for this, okay, as the water is poured slowly. So let us write the answer. The answer will come in this format, okay. So I think we can wrap out the question and write the answer. Write down incident rays coming. Answer, okay. So answer is incident rays coming from the point on the coin, from a point on the coin, from a point on the coin, refracts away from the normal, refracts away from the normal as the enter from the denser medium, from the denser medium, which is the water, from the denser medium, water, into the rarer medium, into the rarer medium. In this case, the rarer medium is the air above it. Air. Full stop. As a result of this, on producing the refracted rays, on producing the refracted rays backwards, the point image is formed. The point image is formed, which is raised, okay, which is raised above the real coin. The image is above the real coin. The same phenomenon, okay, the same phenomenon takes place for all the points, on the coin, full stop. Thus the image of the coin appear raised. Thus the image of the coin appear raised, okay. Therefore the coin is visible after the water is poured. Therefore the coin is visible after water is poured into the bowl. After water is poured into the bowl. Okay, so which was not visible you were able to see because the image of the coin has been raised. Because of the refraction from water to air, the image is raised. Okay, so next one more question there, 46. 46, you'll just understand it's an important question, so we'll just write the question answer. Okay, so here, question note 46, you can see there. If you have the question note, no need to write the question, just write the scribbling on your question copy. Those who don't have, you can write this one. The full thing here, a pencil. We have done this in the previous classes, so this is just a sub question, a pencil. Okay, a pencil immersed means put inside in different liquid. These questions may come out as objective, that's why we're doing it. Different liquids, say water, comma, kerosene. This is on your textbook, kerosene. And turpentine, that is another liquid. Turpentine is also a liquid. Turpentine. Do not get displaced. Do not get displaced means the image is not bent, okay? Bent to the same extent. Do not get displaced means the image does not get bent. The pencil image does not get bent to the same extent. We will see this extent. This proves that the degree of refraction, is different for different sets of media, for different sets of media, plural. That is, the meaning of this one is, that is, after full stop, that is, degree of refraction from water to air, okay, is different from glass to air, The answer here is yes or no, and you tick the yes. What it means is this one. There is a case here. This is water, let us say. Okay, you can draw this bill on your notebook if you want. This is kerosene, let us say. This is turpentine, let us say. Turpentine. Then all these three are liquids, and when you put your pencil here, this is the real pencil. Okay, let us say this one, real pencil, then it will get bent here, and you will see the image of the bend. Whenever you put a pencil in water, you see it bend, right, the image. The same thing if you put a pencil in the kerosene, here also it bend, but the bend is less. Maybe, then you put a pencil here, then here also the pencil is bending less. The maximum bending happen in water, let us say. Less bending, and here medium bending, let us say. Example. Now since the same pencil put in three different liquids is bending differently, different amount, that proves that as the light ray enter from water to air, or kerosene to air, or turpentine to air, all of them will refract away from normal because it's entering from denser liquid into air. But the amount by which it bends is different. That's why the amount of bending is also different. That's what the question is saying, yes. So when the light ray enters from glass to air, the amount it bends will be different from when it enters from water to air. Second medium is same. Glass to air, water to air, but the bending is different. Even though in both cases, it's bending away from the normal because it's entering from glass or water to air, which is denser to rarer. The amount of bending is different. That is yes, okay. So this concludes the class This class will continue in the next class. Okay.